All right, so before we move on and do some practice, let's kind of sum things up and go through this and make it as simple as possible. We'll come back to this again tomorrow. We'll keep doing this and so forth, so you can try and really understand this concept and be able to answer these questions. So remember the goal of the Chateliers. The goal is to reduce the change, right? Whatever is done to that system, you want to try and reduce that change. If something's added, we take it away. If we put something, we want to take it away. If we take something away, we want to put it back. So reduce the change. And then again, think of it as 3 steps. 1, stress is applied. That's not what we want. 2, the system responds. That's our shift. And then 3, what are our new concentrations? How have they changed? And to help you figure things out, remember the basics, right? You always want to shift away from whatever's added. Shift away from added. You want to shift towards what's taken away. And then remember how your concentrations changed. Whatever you shift towards increases, and whatever you shift away from decreases. So this is it right here. This is Le Chatelier on one slide. So these are the basics. Keep coming back to this. Use this as a reference, and it'll make your life easier when you're trying to answer these questions. All right? So now let's do some practice problems. So, bunch of stresses. So remember, stress is applied, system responds, how have your concentrations changed? Stress is applied, system responds, how have your concentrations changed? So we're using the same reaction up top. All right, so notice here, we put this little down arrow in there, add it in, it's not on your sheet. So if we add nitrogen, there's my nitrogen. I want to shift away from what's added, so I'm going to shift right. Whatever I go towards gets bigger, and whatever I go away from gets smaller. So we'll do the next one as an example. What if I add hydrogen? So here's my hydrogen. So you're going to shift away from what's added. So hydrogen's on the left, so I'm going to shift right. So what does that mean? Whatever I go towards gets bigger, and whatever I go away from gets smaller. So my reactants go down, and my products go up. All right? So it's not too bad. Take a couple minutes, pause this video, try the rest of these out, and then come back on and we'll review it. All right, so now I'm assuming that you've done this. And let's check it out and see what we get here. So if I add ammonia, I'm going to shift away from what's added. So here's my ammonia, but it's on the right. So I'm going to shift left. So now whatever I go towards gets bigger. Whatever I go away from gets smaller. Now the next ones we're taking away. So just pay attention to where stuff are, and we keep thinking, all right, whatever I'm taking away, I want to put back. I want to reduce the change. So I want to shift towards what's taken away. So if I take nitrogen away, I want to shift towards it. And then if I'm shifting left, I know whatever I'm going towards gets bigger, and whatever I'm going away from gets smaller. And then the last one, the next one, sorry, taking hydrogen away, same thing. You want to shift left. Whatever you go towards gets bigger, whatever you go away from gets smaller. And then if I remove NH3, NH3 is over here, So now, if I take it away, I want to put it back, but I want to shift right, which means my reactants go down, my products go up. Number 7, temperature now. Temperature is 7 and 8. If I increase the temperature, so say, where's my temperature? It's right here. It's my energy. It's in kilocalories, whatever. Think of that as joules. It's your energy. So if I increase the temperature, I want to shift away from what's added. So I want to shift left, which means my reactants go up, my products go down. And then vice versa. If I decrease the temperature, I want to shift right, which means my reactants go down and my products go up. So last one, pressure, tricky one here. So first look at your reaction and say, okay, how many gases are involved in this reaction? So I have nitrogen and then 3 hydrogens on the left. So 1 mole of nitrogen, 3 moles of hydrogen. So there's 4 total moles of gas on the left, only 2 moles of gas on the right. So if I increase the pressure, I want to shift in the direction that's going to bring the pressure back down. So I want to go to the side with less gas particles, which in this case is the right side, because I'm going to get less collisions, and that's going to bring the pressure back down. Reduce the change. All right, so I want to shift right. Once you get the shift, though, you know it's all the same. Whatever you go towards gets bigger, and whatever you go away from gets smaller. And then if I decrease the pressure, I want to go to the side with more gas particles, because that's going to bring the pressure back up. So I want to shift left, which means I'm going to get more reactants and less products. All right? So flip over to the back of this ditto. You could do this side as well. So take a couple minutes, work through this, and then come back and check your answers. And when you're all done, take a look, see how you did. And now as far as pressure goes, you got to count your gas particles. So there's 2 moles of gas on the left, 2 moles of gas on the right. So this is an important thing, because you'll see this once in a while. If you have the same amounts of gas on the left and the right, if you increase or decrease the pressure, neither side is more favorable. Shifting to one side or the other isn't going to give you more collisions, less collisions, and reduce the change. So when you have equal numbers of gas particles on each side, nothing happens when you change the pressure, because shifting isn't going to do anything. Neither side is going to change that stress that was applied to the system. All right? And now the last thing I have is this part, the bottom part of the back of this worksheet. And I'm going to show you a little demonstration to help you along with this. So I have my props all set up here. So the only thing I want you to do is, I didn't change these on your sheet. So fix that, change the Na to Mg+2. And all we're really going to do is focus on one thing here, because you get a cool little visual. So let me show you my example here. I got some water. And then this stuff is some milk of magnesia, only the finest. I'm going to use this for my demonstration because it is magnesium hydroxide. So it's a base, but it's not very soluble. If we remember back to our solubility guidelines, we look on here. If we go to table F, hydroxides are insoluble. Magnesium's not an exception, so it's pretty insoluble. See? Made cloudy substance. So it's a lot of stuff in suspension here. It looks kind of like milk. So it's not very soluble. But I'm going to use the Chateliers to force this substance to become more soluble. So right now it's insoluble, which really means it's a low solubility. So if it's a base, I'm going to add a little phenolphthalein, and that's going to make it turn pink. So let's swirl that up. See, it's turning a little pink there. So now, to help me along with this process, I'm going to put a little stir bar in there and get this thing stirring. going. You'll see some action in a minute. I'll put a little more phenolphthalein in here. Ooh, nice. There we go. Now it's stirring nice. I keep things moving so it'll distribute things when I add them. So now, what am I going to do here? I'm going to add an acid. So I've got some acid here. So I'll use some vinegar. We'll try the vinegar out, see how that works. So watch what's going to go on here. If I pour this in, think about what's going to happen. If I add an acid, remember what that's really doing. It's removing hydroxide. Because just think of your seesaw, acids and bases. Right now it's basic, a lot of hydroxide. If I add my acid, H plus goes up, OH goes down. So my stress is really removing hydroxide. So watch what happens when I do that. I pour some of this in, look, it goes colorless. Because I took the hydroxide away, so now it's not pink anymore. So now we've changed the concentration of H and OH, but look what's happening. It's turning pink again. Slowly it's turning pink again. Why is it turning pink again? Because the equilibrium is shifting and the system is responding by reducing the change, right? So I had a lot of hydroxide, added my acid, H plus went up, OH went down, but now the system is responding by reducing the change. And you're seeing the shift, right? So slowly, the system is shifting in a way that's going to put the OH back that I took away, and then it goes back to pink again, right? So what did we do? We shifted in the direction of what was taken away, towards what's taken away. So here's my OH. So I'm shifting right. So by me removing hydroxide, I'm shifting right, which means whatever I'm going towards goes up, and whatever I'm going away from goes down, right? So that's what happened here. So I can keep doing it. Ready? Watch. There we go. I removed hydroxide, went back to white, but now the system is responding by reducing the change. And we're seeing it shift right. You're watching the shift. See it shift right, and it's reducing the change, right? It's putting back the hydroxide that I took away, all right? So we're seeing Le Chatelier's at work right here. But remember, these are not infinite amounts of substances that we're dealing with. I can use them up. So if I keep shifting and shifting and shifting, I can't do it forever, right? Watch what's gonna happen. As I keep adding more, look, it went back, it's going, it's shifting again. But every time I shift right, I'm breaking down more and more insoluble magnesium hydroxide and making more ions in solution. So every time I do this, I'm getting less and less reactant and more product. So if I keep doing this, what's eventually going to happen? I'm going to use up all of my reactant. So let's try and speed this up a little bit by shifting to something a little bit stronger. So I got some hydrochloric acid here. And look, you can already see what's going on. But now watch, if I put some of this in, look what happens. Oh, there it goes. Look what happened. Now it's clear. So it's all clear. There we go. So I just made a clear solution. Why is it clear? Because I shifted it so far right that I used up all of the reactant, and now I've forced an insoluble substance to dissolve. Look, it's totally clear now. I shifted it so far right, and that's pretty cool, all right? And that's all I have for today. Thanks for joining me. See you next time.